Grade 9. The strand is measurement. So measurement deals with area of different shapes, where we have this strand. The substrands deals with the area of the pentagon and the hexagon, the area of the cone, sphere, triangular prisms, and others. So we will start by area of pentagon and hexagon. Hexagon. So hexagon is a 6-sided figure. So when you count these sides must be equal. They are equal. So when I'm drawing, they might not be equal, but assume all of the sides are equal. So this side and this side, all of them are equal. So we start 1, 2, 3, 4, 5, 6. This is the hexagon. So when you want to calculate the area of the hexagon or the pentagon or a circle subtends 360 degrees at the center of either a pentagon or a hexagon, even a circle. Therefore, if now we want to calculate the area of this pentagon, we can divide this pentagon or hexagon, using this number of sides to form triangles. You can do like this, you form a triangle. You do like this, you form a triangle, like that. Now, if you calculate the area of one triangle, you will exactly get the area of the others, because this and these triangles are equal the way we have divided them. But we are going to make use of the Pythagoras theorem very much. I know you know the Pythagoras theorem, but I would like to remind you. Here, Pythagoras theorem, we use a right-angled triangle. This is what we are going to use in this topic, in this strand. So this is a right-angled triangle. This longer side is called the hypotenuse. This is the base, and this is the height. So if I give the height letter A, the base letter B, and the height letter H or C, then you need to know, and I know you know, that A squared plus B squared will be equal to C squared. This is called the Pythagoras theorem. So for any right angle triangle, that is the case. So the reason why you must know this is that in these triangles here, you will be given the length from here to the center, because the length from here to the center is equal. So this one is going to form an isosceles triangle. We are going to extract a triangle of this nature. So if I call this one center OAB, we are going to extract OAB. This and this are equal. You will be given the length from here up to here, like it is 10. The length from here up to here is 20. Right? So, why is it important for you to know? For us to calculate the area of a triangle, we need a half base times h times height. But this triangle, we don't have the height. So it is your duty now to divide this into 2. And once you divide, it forms a right angle triangle. Here we have 5. Here we have 5, because from here AB is 10. Then the center, if you divide it, it will be 2, 2. 5, 5. Now we have a right angle triangle looking like this. From here up to here is 5. From here up to here is 20. so we need h. We know that h square plus 5 square will be equal to 20 square. So h square will be equal to 20 square minus 5 square. H square equal to 400 minus 25. H square will be equal to 375. So to get h, you find the square root of both sides. Find the square root, the square root. So h equal to 19.36, the square root of 375. So this is how we get the height. Now let's use an example. Find the area of a pentagon, the pentagon below. Each side is 10 centimeter and the length from one corner to the center is 20 centimeter. So what you need to do is to join and form a triangle. So if you join this to this, it's another triangle from here to there. So you can join and see how many triangles will be there. We expected to be 5 because we have 5 sides. There should be 5. So 1, 2, 3, 4, 5. There should be 5. Now calculate the area of one triangle, then multiply with 5 of them. Now we know from here up to here is 10. But from here up to here is 20. From here up to here is also 20. This is 10, this is 10, this is 10. All sides are equal. Because these are called regular. We are dealing with regular pentagon or polygons. Regular. Now if that is the case, what you need to do is to extract this triangle. And this triangle is called isosceles. Isosceles because this side and this side are equal. Therefore it is called an isosceles triangle. So here is 20, here is 20. You need the height for you to calculate. So from here up to here is 10, therefore here is 5, here is 5. So what you need first is the height. You use Pythagoras theorem like I was explaining earlier. So here, this is 5, this is 20. You say h square plus 5 square would be equal to 20 squared. H square plus is equal to 400. This one comes this side minus 25. H square would be 375. So the square root of both sides will give you the height, and that is 19.36 centimeters. We know that the area of a triangle, now we want to calculate the area of this triangle. A half base times height, which is a half, times the base, which is 10, times the height, the one we have calculated, 19.36. This one will give us this one here 5. 19.36 times 5, that is 97.5 centimeters square. So this is the area of one triangle. But how many triangles are there? 1, 2, 3, 4, 5. So you multiply times 5. 97.5 times 5. Therefore, the total surface area of this pentagon, is, you multiply, that is 487.5 centimeters square. So if it is a hexagon, you calculate the area of one triangle, then multiply times 6. If it is heptagon, octagon, nonagon, the same. If the sides are 10, like the decagon, you multiply times 10 sides. Our next substrand is surface area of a rectangular prism. I have drawn a prism here. So this is a rectangular prism. The base is a rectangle, you can see. So in fact, all of the figures here are rectangles. So we have how many rectangles, how many faces? 1, 2, 3, 4, 5, 6. So this rectangular prism has got 6 faces. Now we need to calculate the area, but before, you should know that from here up to here is the length, from here up to here is the width, and from here up to here is the height. We are going to use H to represent the height, W to represent the width, and L to represent the length. So to calculate the surface area, you can see this side here, A, B, C, D, is exactly the same as side E, F, G, H. These are two triangles that are similar. A, B, F, E is the same as D, C, G, E. They are the same, right? Rectangle A, E, G, C is the same as B, F, F, E, D. They are the same. So to calculate the surface area, we need to calculate the surface area of each triangle and then multiply times 2. So the area of this triangle, this prism is equal to, we start with this one, which is length times height, because there are 2 there, and the other one times 2, plus this one, which is 2 into width W times height, because this one and this one are the same. Next, we calculate the area of this top, which is 2 plus 2 into, this is length times width. So to calculate the area of a triangular, this is the formula you're going to apply. Surface area of a rectangular based prism. This is a rectangular based prism. You can see these are rectangles. Now we have this rectangle A, B, C, D. This is a rectangle. E, F, G, H. So to calculate the total surface area, first you calculate the area of rectangle A, B, C, D. That is length times H, because this is times H. Then this one is also G, E, G, E, F. Okay, let me even say this one is J. G, J, E, F times 2, because there are 2. You add, we have calculated this one and that one. Now let's calculate C, E, F, D, which is W times height. Then this one is also this one times 2, plus the top and the bottom. A, G, C, E, which is length times width, but it is on the top and the bottom. There are 2 of them. So this is the total surface area of any rectangular based prism. Find the total surface area of the figure below. So this figure here, it is your duty to connect it like this. It might not be connected initially, so it is you to know that there are other rectangles there. So we have this rectangle, which is length, width, height. So if from here up to here is 5, it means from here up to here is 5. If from here up to here is 8, it means from here up to here is 8. If from here up to here is 10, from here up to here is 10, from here up to here is 10, from here up to here is 10. So area will be equal to length times width times 2 plus width times height times 2 plus, we have done this length times width. So length times width means the bottom and the bottom and the top. Then I have done the width times height, this one and this one. So I'm remaining with this. Length times height. Length times height. And there are 2. Now substitute the numbers. This is 10 times 8 times 2 plus 2 into width, which is 8. This is 8 times height, which is 5, plus 2 into length, which is 10, times height, which is 5. This is 80, 160 plus 40, 80 plus 50, 100. So this gives us the total as 340 centimeters square. 340 centimeters square as the total area. Surface area of a triangular-based prism. This is a triangular-based prism. This triangle you see here and this triangle, they are similar and they form the cross-section area. They formed what? The cross-section area. So the cross-section area is the shape which is the same. This one and this one are exactly the same. But we cannot say that this rectangle here is exactly the same as this one. That one may not be true. But this triangle here and this triangle, they are exactly the same. Like when we have a cylinder, right? This region here and this top here, they are equal. They are similar. They are the same, right? Because it is a circle and this is a circle. Therefore, they form the cross-section area. So this triangle and this triangle, they are the same. They form cross-section area. Cross-section. It's important because I'm going to use this word cross-section. So to calculate the area of a triangular-based prism, we approach it this way. We have 2 methods. We will do both of them. So you can see very well, this is an isosceles triangle. So from here up to here is 13, from here up to here is 13, meaning from here up to here is also 13. From here up to here is 10, because from here up to here is 10. From here up to here is 20, because from here up to here is 20. You will need to know that. So we can start by calculating the area of this triangle and then multiply times 2, because this and this are the same. So area of the triangle. So this being an isosceles triangle, we cannot calculate it like that because we do not have the height. We need to get the height. So from here up to here is 10, this is 13, and this is 13. So we want this height. You divide this isosceles triangle into 2 and it forms a right angle triangle. Extract one right angle triangle like this and use it to get the height. This is 5 because if it is 10, you divide by 2, you find 5 here, 5 here. And this is 13. We want this. We know from the Pythagoras theorem that h square plus 5 square will be equal to 13 square. H square will be equal to 13 square minus 5 squared. And this is 169 minus 25. That is 144 h square. Meaning to get h, you find the square root of both sides. So h is equal to 12 centimeters. H is equal to 12 centimeters. Now we have the h. Now we can calculate the area is equal to a half base times height. Our base is 10, that is a half times 10, then times the height we have obtained, which is 12. So by so doing, we have calculated the area of this triangle here, but there are 2 of them. To multiply here times 2. So you can cancel here 1, here 5. This times here, that is 60 times 2, and that is 120 centimeters square. So the area of these 2 triangles is 120. Next thing is to calculate the area of the 3 rectangles. We have this rectangle, we have this rectangle, and we have this rectangle. So let's start with the bottom rectangle. It is length times width, which is 20 20 times 10. That is 200. Next one is 13 times 20. And that is 260 centimeters square. The last one is this. That is 13 also. 13 times 20, and that is 260. Now to get the total surface area, you add this, and this. So total will be equal to 260 times 2 plus 200 plus 120. And that gives us 840 centimeters square. Now that is how you do. But I have a very simple way of doing it. Method 2. Instead of calculating this way, there is this way. There is a formula I'm going to give you that says surface area is equal to area of cross section times 2. So you identify the cross section area and find the area of that cross section. Then you multiply times 2. Then you add perimeter of cross section, then times length. And that is done. So let me explain what cross section area. I've told you those two faces that are same, that are exactly the same, is what we call the cross section. Like here, this triangle is the cross section area. This long edge here is the length, right? Now let us apply the formula. So cross section area, we have calculated the area of the triangle. The area of the triangle you will do the same way we have done here. So the area of the triangle will be a half base times height, which is a half times 10, the way we have done. We calculate here, you must have calculated the height the way we have done here up to this. Then get the area like this. So that is times 12, and then times 2, because cross section area times 2, right? Then plus perimeter of cross section. Now get the perimeter of cross section. Perimeter of cross section, 13 plus 13, 26 plus 10, that is 36. So the perimeter is 36. Then times length. Length is this, the longer side, that is times 20. So this is 120 plus 360, which is 720. When you add, you get that the area will be equal to 840 centimeters square. So we have gotten, look at the space we have used and look at the way we have done. So this method seems to be very simple and very straightforward. Find the total surface area of this diagram here. You can see this is a triangular based prism, right? So what you need to do is to use the formula I've given you. Which one is the cross section here? It is this triangle and this triangle. They are exactly the same. Therefore, what you do, get the area of this triangle, extract the triangle here. From here up to here is 12. This is 10 and this is 10. Divide it into 2 to get the height. So we will have a right angle triangle of this nature, whereby from here up to here is 6, from here up to here is 10. So we want height. So height square plus 6 square will be 10 square, meaning that height square will be 100 minus 36. You take this to the other side. It means that h squared is equal to 64. So to get h, you find the square root of h square. And that gives us our height is, now calculate the area of cross section. So the formula is area will be equal to area of cross section times 2, then plus perimeter of cross section times length. So what will be the length in this one? 15 is the longer edge, therefore this is the length. The longer one is the length. So this one will be a half times base. The base is 12 times height, which is 8. Then times 2 plus perimeter of cross section. So from up to here is 10, this is 10. So 10 plus 10, 20. Plus this 32. So that is 32 times length, which is 15. Right? Now, this one goes here 4. So this is 48 times 2 plus 48 times 2 plus 32 times 15, that is 480. So 96 plus 480, and that gives us 576 centimeters square, and that is the total surface area of this figure. Now use the other method, calculate the area of this, add the area of this rectangle, area of this rectangle, and the area of this rectangle, and you will confirm that the area is the same as this. Surface area of pyramids. We have 3 types of pyramids. We have a square-based pyramid, triangular-based pyramid, and a rectangular-based pyramid. Like this one is a rectangle, therefore it is called a rectangular-based pyramid. So if I give you the length from here up to here is 8, from here up to here is 6, and I give you 1, this edge here is 10 centimeters. Then to calculate the area of this rectangular based pyramid, you need to draw the net of this, something like this. Something like this. This is the rectangle, which is 8 and 6, right? From here up to here is 10, from here up to here is 10. 10, 10, 10, 10, 10, 10. It is the same. From here up to here is 8. From here up to here is 6. Now what you need to do is to calculate the area of this triangle and multiply times 2, because these and these are equal. Calculate the area of this triangle, multiply times 2, and then add the area of this rectangle. Let's start by calculating the area of this triangle here, and remember what we are missing here is the height. So we will take that and calculate the height first. This is 10, this is 10, and this is 3, this is the 4, 4. I've started with this rectangle here, 8, 10, 10. So I'm going to get the height. Height squared is equal to 10 square minus 4 squared. H square will be equal to 84. So H equal to the square root of 84, and that will give me the height. Say 16, that is 86. So H will be equal to 9.17. Now we calculate the area, which is a half base. The base is 8 times height, which is 9.17. But remember, there are 2 of them, this and this. So you multiply times 2. That one will give us the area, which is equal to 73.36 centimeters square. So far we have calculated the area of this and this. Now let's calculate the area of this and this. This is a 6, this is 10, 10, 6. So you divide by 3, 3. So 6 will give us 3, 3. We have this right angle triangle. It is important to understand very well Pythagoras theorem, H, 3. So H square will be equal to 10 squared minus 3 squared. H squared equal to 100 minus 9. H squared equal to 91. So let's get H by square rooting both sides. That would be 9.54. The height is 9.54. So area of the triangle will be equal to a half times 6 times height, 9.54. Because they are 2, this and this, you multiply times 2. And that one will give us 57.24 centimeters square. Now we are remained with the area of the rectangle. Rectangle area is equal length times width it. That is 6 times 8. That gives us 48 centimeters square. Now total area is to add this, this, and this. That is the total surface area of that pyramid. Find the area of the figure below. This figure is a square-based pyramid. You can see that the base is the square of 4, 4, right? Therefore, let's draw the net for this. The net will look something like this. So this is 4 and this is 4. 10, 10, 10, 10, 10, 10, 10, 10. Now calculate the area of one triangle and then multiply times 4 because these triangles are the same. Why? Because this is a square. So this one is very simple. Take one triangle, 10, 10, divide it, have 2, 2, get the height. Height square will be equal to 10 square minus 2 square. H square will be equal to 96. Therefore, H will be equal to the square root of 96. That one will give you the height, and that is 9.8 centimeters. So now area of one triangle will be equal to a half times base, which is 4, times height, which is 9.8. Now you multiply by how many? 1, 2, 3, 4 times 4. For the square base, it is simple. So this one you cancel here 1, here twice, and the total surface area for those triangles will be equal to 39.2 centimeters square. Now we remain with the area of the base, that is length times length, and that is 4 times 4, 16. So total surface area will be 16 plus that 9.2, and that is 55.2 centimeters square. Area of a sector and a segment. So we have a circle. If we draw and subtend an angle at the center, this shaded region, this one is a minor sector. This one unshaded region is the major sector. Right? So this theta here is the angle subtended at the center of this circle. Now to get the area of a sector, we use the formula area is equal to, remember the area of a circle is pi r square. But since we are calculating a region which is subtended by a certain angle theta, therefore now we say it is theta over 360 pi r square. So this is the formula of calculating as area of a sector of a circle. R is the radius, pi is 22/7 or 3.1423. Calculate the area of the figure below. This is the figure. They have given us the radius and they have put something here. So whenever you see this sign, This sign shows that it is 90 degrees. Therefore, the angle subtended at the center is 90 degrees. So whenever you see this is a perpendicular, meaning 90 degrees. So we apply the formula theta over 360 pi r square. 90 over 360 times 22 over 7 times radius, 7 times 7. Now you cancel. This goes 1 here, 4. 7, 1, 7, 1. 2, 2, 2, 11. So this one is 77 divided by 2, and that one is 38.5 centimeters square. That is the area for that sector. Find the area of the diagram below. So this is the diagram, is a sector. Therefore, formula is theta over 360 pi r square. So that is 60 over 360 times 22 over 7 times the radius, which is 14, times 14. Now cancel this and that. 6, 1, 6 here, 6. 7, 1, 7 twice. 2 ones here, 3 i's. Now, so that gives us 192.67 centimeters square for that figure. Calculate the area of the shaded region. You can see this figure here. It is formed by a rectangle. This rectangle has got the ends of a right angle triangle here. This is a right angle triangle, 90 degrees. So first we can calculate the area of this rectangle. The area of the rectangle, length times width, which is 14 times 7, and that gives us 98 centimeters square. That is the area of the rectangle. Now we can calculate the area of the unshaded region. Unshaded, the one which is unshaded. We start with this. If from here up to here is 14, then from here up to here is 7, and this is 7. Also this is 7. We have been told so. Therefore, this means the angle subtended here is 90, because you can see this is a quarter a circle. A quarter a circle. A quarter circle is 90 over 360 times 22 over 7 times the radius, which is 7 times 7. 2, 2, 2, 11. So this one is 38.2.5 centimeters. Right? 1 here. But this and this are the same, so you can multiply times 2 and get 77 centimeters square. Now the area of the unshaded is 77 centimeters square. Now to get the area of the shaded, it is the area of the whole rectangle minus the area of the unshaded, this and that. That is 98 shaded. 98 minus 77, and that is 21 centimeters square. That is all you need to know.